We're going to take a look now at scalar multiplication. So this word scalar, it was in your notes, but just to go over it, scalar is a quantity. It's a magnitude quantity. It doesn't have any direction. And so when we multiply by a scalar, we're going to be changing the length or the distance that we travel. So this was earlier in your notes. I want to take a look at the pictures again to get an idea of what this actually would look like if you were to graph these vectors. So here we have this vector v with a length v. And now here we have multiplied vector v by 2. This 2 is what we refer to as the scalar quantity. So if we look here, here's v, and so if I can do this, here's v, and then starting from here, there's 2v. So this length here is 2 of these. If I could move this and put it right on top of one another. Notice the direction hasn't changed. It still has the same slope. The direction is the same. It's just the length of this is now changed. This is twice this. As I said, 2 is that scalar. Here, we're looking at 1/2 v. So this is 1/2 of this original v. Again, no change in the direction. This is just, we can see much shorter. It's half of this v, and 1/2 is the scalar that has been used. Here, the scalar is -3/2 v. Again, we can see the slopes of all of these are the same, so we're not changing the direction. What we're changing is, well, let me back that up a minute. With this negative, we are changing the direction, not the slope, just the direction that we're traveling in. This, we have two things going on. The 3/2, we've changed the length of this v here. This, if we were to measure it, would be 1.5 times this, the 3/2. And now we've changed the direction. So instead of starting with an initial point here and traveling in this direction, the way we did in these three, now we are starting here at this point and going in the opposite direction. So just a visual of what scalar multiplication looks like. And remember, if your scalar is a positive, you're going in the same direction. If it's a negative, you're going to be going in the opposite direction. Now let's take a look at some of these examples. If we are multiplying by a scalar, we just took a look at what the picture of it would look like. What is going to be involved is that this k here, which represents a scalar quantity, again, just a magnitude, is going to be applied or distributed, if you will, to the I and also the j. So we're going to multiply A by k and then B by k. So in this first example here, we're looking at 8v. So what we're going to be doing is our v is 7i plus 10j. So we're going to be looking at 8 times 7 for our I, and then 8 times 10 for our j. So 8 times 7, we have 56i, and 8 times 10, we have 80j. So this vector here, same direction as our original v, but now we can see the magnitude is going to be much longer. In fact, it's going to be 8 times longer. This example, our k now is -5. So we have -5 times our 7 for our I, and then we have -5 times 10 for our j. -5 times 7, we have -35 I, and -5 times 10, we have -50j. So here we have changed the magnitude of our vector. It's now 5 times. So if we were to find the magnitude of our original vector v, and then find the magnitude of this here, because we know how to find magnitude, we would see that this magnitude was indeed 5 times bigger than this magnitude. In this example, not only did we change the magnitude or the length of the vector, but we are going now in the opposite direction. And now for this final example of a scalar multiplication, we're going to combine two things. We're going to combine two scalar multiplications, because we're going to multiply vector v by 6, and then we're going to multiply vector w by -3, and then we are going to be adding these two vectors. So first, let's take a look at 6 times vector v. So 6 times vector v is going to be 6 times 7i plus 6 times 3j. So this is going to be 6 times 7, 42i, and 6 times 3, we're going to have 18j. So there's the multiplication involving v. So now let's take a look at w. So vector w, we're multiplying by -3. So -3 vector w. And this is going to be -3, and now times 4, and this is I, -3, how can I write this? Times -5, I'm not too keen on how that looks, but okay, -3 times -5j, and doing this multiplication, -3 times 4, we have -12i, and -3 times -5, we have 15j. So we've changed the magnitude of w, and also we've changed the direction of it. So we've done our scalar multiplications, and now we're going to add these, because, actually no, well, I'm going to put them together using addition now, because this was a subtraction, but I took care of the subtraction when I changed this to using -3w. So when we put these together now, so our 6 vector v minus 3 vector w, this is going to be, we have 42 minus 12i, so the 42 and the -12 in front of our i's, and then we have 18 from this vector, and we have 15 from this vector. And there's our j. And now 42 minus 12, this is 30i, and 18 plus 15 is 33j. So you can see that before I fade off into the sunset.